everyone. So in the last 4 days I couldn't do the classes because of Ganesh festival. A lot of loud sound is there. So sorry for that. And today I am continuing the same lesson, metals and non-metals. So in that we are mainly discussing about the extraction of metal from concentrated ore. So first I'll write down the heading, metals and non-metals. Metals and non-metals. So what we are doing today mainly is extraction of metal from concentrated ore. Okay, so we have discussed the four methods of in the concentrated ore, that is hydraulic washing, magnetic separation, chemical separation and transportation process. So today I am going to do the extraction of metal from concentrated ore. So in this only there are two steps are there. First one is conversion of ore into its oxides. Conversion of ore into its oxides. And second one is what? Second one is reduction of metal oxide to metal. Reduction of metal oxide to metals. So these two steps are there in case of extraction of metal from concentrated ore. So again, conversion of ore into its oxide. Here there are two steps are there. One is calcination. Calcination, it's mainly done for carbonate ores, and one is roasting. Roasting, it's mainly done for sulfide ores. So I will discuss it. What is calcination and what is roasting. So what is meant by calcination? It's mainly done for carbonate ores. For example, now calcium carbonate we can take. Calcium carbonate, we are heating it in the absence of oxygen, because already oxygen is there, so no need of oxygen again. So we are heating this calcium carbonate in presence of heating, in the absence of heating, and then we are getting calcium oxide, calcium plus CO2. So this is the compound of calcium oxide plus CO2 or zinc blend, that is zinc carbonate. So zinc carbonate we are heating in the absence of oxygen, we are getting zinc oxide plus CO2. So this is the process of calcination. So I will just write down the definition here. Carbonate, heating ore in the absence of oxygen, below its melting point is called calcination. Okay, next we are discussing about the roasting. Roasting, this method is applicable only for sulfide ores. But in case of roasting, we are in the presence of oxygen, we are doing the reaction here. So roasting, it's mainly done for sulfide ores. For example, we can take a HGS, that is called cinnabar. This mercury sulfide we are heating in the presence of oxygen, we are getting mercuric oxide plus SO2. So this is about the roasting. We are heating in the presence of oxygen, then we are getting mercuric oxide plus SO2 in case of roasting. So again we can take in a zinc blend. We are heating in the presence of oxygen, we are getting zinc oxide plus SO2. So this is about the roasting. So I'll write down the definition here. Heating sulfide ores in the presence of oxygen but up to below its melting point only we are heating it, otherwise it will melt. So heating sulfide ore in the presence of oxygen below its melting point. below its melting point is called roasting. So these are the two steps for the conversion of metal to its oxide form. Now again we have to do the reduction of metal oxide to metals. Reduction of metal oxide to metals. Reduction of metal oxide to metals. So this reduction of metal oxide to metals, again it depends upon the reactivity of that metals. Reactivity of metals. For example, we are using less reactive metals like mercuric sulfide, mercuric oxide, zinc oxide. So these are the less reactive metals. In this case, we are by heating only we can just convert them into metal. By heating it, we can just convert this mercuric oxide into mercury plus O2. Here again we are heating it. Again we are getting here zinc. So like this we are using this method for the less reactive metals. For moderate reactive metals we need a certain reducing agent there. So which are these reducing agent we are using, that I will discuss. So in case of moderately reactive metals, we are using certain reducing agent. One is coke we are using. Next we are using monoxide, carbon monoxide. And again we are using aluminium. So these are the reducing agent we are using for the moderately reactive metals, for the reduction of metal oxide to metals. Aluminium. Okay, so coke, first we can take an example of Fe2O3 plus coke, that is C, and we are heating it, then we are getting Fe, pure iron, plus CO2. So this is in the case of less moderate reactive metals. For example, now Fe2O3 we have taken, we have done already concentration of ore. In that we will try to remove the impurities, but still there are certain impurities. So that impurities we have to remove in this case. So what we are doing, so along with this Fe2O3, one impurity will be there, that is called SiO2. So it is not completely removed. So again we have to try to remove it. For that purpose we are adding certain flux. So what is meant by flux? Flux, a substance added to remove the impurities from this metal oxide, is called flux. So we are using which flux here? Calcium oxide. So now we are using SiO2 plus calcium oxide, then we will get here CaSiO3. So because of this CaSiO3, this impurity will be removed from this Fe2O3 and we are getting pure iron. So this is about the flux, and one more is slag. So there are two terms, one is flux and one is slag. So what is meant by slag? Slag, it is a covering on this metal to prevent further reaction of that metal. For that we are using slag, and flux already discussed, the substance added to remove impurities. Substance added to remove impurities, this is called flux. And we have used here calcium oxide as a flux to remove this silica impurities from this Fe2O3. And we are getting here calcium silicate. So it will be removed as an impurity. So next we are using which carbon monoxide reagent. So Fe2O3 plus carbon monoxide we are using, then we are getting, after we are heating it again, then Fe plus CO2 we are getting. So this is about the carbon monoxide. Now we are using aluminium as a third reducing agent. Fe2O3 plus aluminium. Why we are using only aluminium? There are other certain metals are there which are more reactive than the aluminium, like sodium, potassium, but we are still using aluminium. Why? The reason behind this is less expensive and it is more easy to remove from the concentrated ore. This extraction of this aluminium from earth crust, and this aluminium is abundant in the earth crust. That is the reason we are using aluminium as a reducing agent. So now we can get a compound here Fe plus Al2O3. So this is about the reduction of metal oxide to metals. Again, for the high reactive metals, electrolytic refining is there, so that I'll discuss it tomorrow. So we are using their electrolytes and electrolytic solution. So I'll discuss in a detail about this in a next class. Thank you.